Design and fabrication of Parkinson gear tester. Abstract spur gears are most important part of power transmission system. Damages occurred during manufacturing of gears will result into loss of power and also resulting into vibration. To control such errors, Parkinson gear tester is used. The literature survey shows that Parkinson gear tester are costly and only available for testing of metal gears. The objective of this project work is to design a gear testing system applicable for polymer gears. By trial and error method, different concepts were developed and optimized. Concept interns of manufacturing and ease of use is finalized for 3D designing to understand the actual working of the system. SolidWorks 2015 software is used for 3D modeling of the system. All the parts of the machine are purchased as per requirement of the system. Finally, fabricated model will result into low cost and capable to measure the spur gear teeth profile with least error. This system can be implemented to check the larger gear of OD ranging from 10 mm to 100 mm. This system is also resulting into low manufacturing cost and easy to operate it. Keywords: Parkinson, gear tester, spur gear, frame, master gear. Introduction. In the present world, as everything around us is changing so rapidly, everyone needs to complete their task as fast as possible. Here comes gears, the mechanical components used for power transmission. Everywhere motion is present. Gears are a very vital component of any machine as they are used for power transmission whenever the machine is needed to be operated. Therefore it is very important for the gear to be in a good condition. For achieving this rapidness, man manufactures various machines and equipment are manufactured in order to keep the growth rapid. The engineer must bring new ideas and design into reality. New machines, equipments and the methods are being developed continuously for production of various product at low cost and precise quality. Gear testing is one of the methods used for the testing of accuracy of gears and also to undermine the errors of the gear. In order to check the tooth error, different types of gear testing machines are used. Various machines have its ability to check specified parameters only. Highly precise machine required special installation and space. For the purpose of checking gear in machine shop while performing machine required such an arrangement which is robust and quick one. 2. Objective. A. To design a system to analyze the spur gear profiles similar to Parkinson's gear tester method. B. To detect the spur gear teeth failure using electromechanical system using sensors and dial gauge. C. To design a testing method for polymer gears with different gear parameters. 3. Construction. 4. Working. Parkinson's gear tester. Principle of this gear tester is to mount a standard gear on a fixed vertical spindle and gear to be tested on another similar spindle mounted on a sliding carriage, maintaining the gears in mesh by spring pressure. Movement of the sliding carriage as the gear rotated are indicated by a dial indicator. This dial indicator gives the reading of movement of gears, or it may be said that dial gauge gives the measurement of gear variations. These variations are a measure of any irregularities in the gear under test. Gears are mounted on 2 shafts so that they are free to rotate without measurable clearance. Master gear is mounted on a fixed mounting while gear under test is mounted on sliding carriage. These 2 plates are connected under spring pressure. A procedure for operation of test rig. I mount the reference gear on the sliding carriage. 2. Bring the sliding carriage toward the master gear and mesh the reference gear with the master gear manually. 3. Mount the calibrated spring on the mounting of the master gear and attach it with the sliding carriage. 4. Slide the dial indicator towards the sliding carriage and adjust the dial indicator at 0 reading. V. Set tolerance limits on the dial indicator. 6. Switch on the microcontroller. 7. Check whether the IR sensor is working or not by keeping hand before it. 8. Press the switch on the microcontroller to start the motor. 9. After starting the motor, adjust the position of the sensor till it detects the outer diameter of the gear. X. After adjusting the sensor, observe the dial indicator for the deflections. 11. Record the results manually on a paper for different gears. V. Design calculations. A. Design of frame structure. But the standard angle available in the market is of 25.4 x 25.4 x 1.6 mm. Hence, for safer side we have selected it which can bear the impact loading of 78.48 N. So, our design is safe. B. Design of master gear. Taking 20° full depth profile. P equals 10 kilowatts. N1 equals 100 rpm. Speed reduction, I, equals 3.5. C. Applying frictional contact between the gears. 3. Applying boundary conditions. A. Rotational velocity of 1.0472 rad/sec to the driving gear. Fig. 3. A. Analysis of master gear. B. Applying fixed support to the driven gear. Fig. 4. B. Analysis of master gear. C. Total deformation of the driving gear 2.5195 E5 mm. Fig. 5, see analysis of master gear. D. Equivalent stress on the driving gear is 0.00032 MPa. Fig. 6, D. Analysis of master gear. 6 results. For reference gear of 100 mm outer diameter. Material of gear polylactic acid. Module equals 2. From below table referring for class 2. SR no. Accuracy. Profile tolerance. 7 advantages, disadvantages and applications. A. Advantages. 1. Equipment suitable for mass production for inspection of gear. 2. Quick results can be obtained. 3. The accuracy is of the order of plus or minus 1 micron. 4. Measurements are directly dependent on master gear. B. Disadvantages. 1. Low friction movement of the floating carriage. 2. Errors are not clearly identified for type of profile, pitch, and tooth thickness. 3. Measurements are directly dependent upon reference or master gear. 4. Rolling does not reveal all types of errors. See applications. 1. It is used to check as well as measure errors in tooth forms. 2. It detects errors in pitch of the gears. 3. It detects errors in concentricity of pitch line. 4. It detects the total composite errors. 8. Conclusion. A. The designed Parkinson gear tester can be used to test the gear teeth profile on the spur gear made of polymer material. B. These types of system can be used for gear with different outer diameter varying from 20 mm to 100 mm. C. Motor placed in gear tester capable to rotate the gear in the range from 10 rpm to 100 rpm with controlled speed. D. This lightweight and high-strength gear tester will help engineers and students to study gear failure with depth knowledge. E. This system can also be used for gear made of polymer material. F. This system will identify the failure in the teeth by blinking the sensors placed near the gear assembly. G. System is compact and well designed. 9 references. 1. Omar Monir Kora, Assessing Spur Gear Quality Using Virtual Rolling Gear Testing Machine, Proceedings of the 3rd International Conference on Mechanical Engineering and Mechatronics, August 14 to 15, 2014. 2. Jagannath Sardar, Dibakar Bandopadhyaya, Evaluation of Wear Behavior of a Non-Metallic Spur Gear, 5th International and 26th All India Manufacturing Technology, Design and Research Conference, AIMPR 2014, December 12-14, 2014. 3. Shinde Dishar B. Shuttle D. Dattatray, Mayuri G. Girhe, Vinod D. Shinde, Vireshma V. Kirkut, Design and Development of Parkinson Gear Tester for Spur Gear to Check the Flank Surface, International Journal of Advanced Research in Mechanical Engineering and Technology, April-June 2015. 4. Nishant Dev Kate, Ashok Bhoi, Shivam Jadhav, Pratik Rot, Test Rig on Parkinson Gear Tester, International Journal of Advanced Research, Ideas and Innovations in Technology, 2017. 5. Professor Dattatray K. Nanaware 1, Professor Kaveri S. Kadam, Modified Parkinson's Gear Tester, International Journal of Science and Advanced Research and Technology, Volume 3 Issue 4, April 2017. 6. EAP Egby, Design Analysis and Testing of a Gear Pump, International Journal of Engineering and Science Volume 3, Issue 2, May 2013, pp 01-07. 7. A.P. Aaron, A.P. Senthil Kumar, B. Giriraj, A. Fazur Rahman, Gear Test Rig, A. Review, International Journal of Mechanical and Mechatronics Engineering, Vol 14-05. 8. www.indiamart.com, for frame manufacture details, Ambika Enterprises, Rabal, Navi Mumbai.